Everyone, I want to thank you all for joining us both in person and online via Zoom. I would like to start by acknowledging that we are located in Mi'kma'ki, the unceded ancestral territory of the Mi'kmaq people. In Nova Scotia, we are all treaty people. Before we begin, I would like to go over a few housekeeping items for this session. Emergency exits are located behind me and as well at the end of the room. Bathrooms are located at the end of the room to my right and at the end of the hall. Masks are required at all times in the facility unless you are eating or drinking. We are joined today by a number of participants online, both as attendees and speakers. Please be mindful not to disrupt the cameras located immediately in front of me, and to be mindful to keep the noise down within the room. And this event is being recorded. For the best virtual experience, audience cameras are off and have been muted online. To all those in the room, I once again ask that you try to remain quiet to reduce background noise for our colleagues online. I would also like to thank all of the elected officials that are joining us here today. We have all three levels of government represented here with us, both in person and online. On behalf of the Valley REAP team, I would like to introduce and give a great welcome to our Member of Parliament from King's Hants, who will be joining us online to offer a few words of greeting.
Thank you, Rochelle. Can you hear me okay? Rochelle, can you hear me? Can everyone hear me back home? I see you.
We can hear you and see you.
Oh, well, my God, seeing me might not be too pleasant as I took the red eye yesterday morning. So Tuesday mornings are always tough for me in Ottawa. But look, thank you very much for the opportunity to be here just to provide a few words. And thank you to the work that the Valley Wren, along with other partners, are doing. I've kind of been briefed on the MIT REAP and the work that is progressing around agriculture innovation in the Annapolis Valley and in Nova Scotia. And it's very interesting work, and I look forward to connecting and hearing even more. But on today's topic, of course, this is of particular interest to me, not only as the Member of Parliament for King's Hants, but indeed as the chair of the Rural Caucus at the national level. And we were having conversations last night about what I foresee to be the two largest challenges for the Government of Canada and for parliamentarians in the next 2 to 3 years. And it's going to be growing our economy to make sure that the expenses that we've had to take on during the pandemic can remain sustainable, and what we want to do in the days ahead has a pathway for it to be financed. And two is climate change. And when I looked at the topics and kind of the discussion that we're going to be having today around innovation, really agriculture, and I would extend that to rural industry, but of course today is about agriculture. The pathway runs through that. We have so much potential. 1 in 8 jobs in Canada are tied to agriculture. It's a $140 billion industry, but we know in the face of climate change that we can both position our sector to continue to feed the world and feed Canadians, but at the same time, we're going to have to use some innovation and technology for us to do that. And I look at a couple examples, one being labor. Right now, and whether it be farmers in the Annapolis Valley or small businesses elsewhere in the country, the pandemic has created challenges in countries around the world, not just Canada, to be able to make sure that we have a steady stream of new immigrants that want to contribute to the country. The labor issue in agriculture has been persistent far before my time in office. I think it's probably a couple decades now, but there's innovation and technology that can be used to help stopgate some of the labor challenges that we know that are being faced in the sector. I think about things around climate. 10% of our GHG emissions in the country are tied to agriculture. And I don't say that despairingly to the folks that are on the call. That's just a reality. And if we're going to be able to meet our climate goals, we have to be able to help find efficiencies and ways to reduce carbon emissions in agriculture. And there's already a lot of good work that are being done at the farm gate level. The government of Canada has put in a series of measures through the last fall economic statement and the budget to help drive innovation in that area as well, but there's more to be done on that. And finally, it's about sustainability on farm. We want to make sure that there's our next generation of farmers who are, my generation, that are going to be stepping up to continue to provide that food security in the days ahead. And so this conference is exciting. I look forward, Rochelle, through you and others, to be able to hear more. I have to be in the House of Commons in about a half hour, so I won't be able to join for the entirety of the program. But thank you for putting this on. Thank you for your interest in driving this conversation, and to our farmers and our agriculture producers who I know are already thinking along these lines. I think about Earl Kidston with the hydroponic strawberries up top, or I think about the things I've seen at Scotian Gold or Apple Valley Foods. There's already a lot of good innovation happening, but let's continue to drive that conversation so that we can be global leading. So best of luck to everyone today, and it's great to see you all virtually.
Thank you so much, MP Boyce. And now I would like to introduce our MC for today, Valley REAP Team Champion, Dr. Wayne Saint-Amour.
Well, good morning, everyone. We're going to start off with just a kind of few things, just to kind of warm things up a bit as far as what's going to happen today. What can you expect? I'm not sure if there's an echo in the room. Are you all hearing? I don't know if there's anything we can do about that. But I'm going to talk a little bit about what this MIT REAP thing is, to give you a kind of sense of it. And first, I'd like to introduce our team, because they're really the backbone of this whole initiative. So the Massachusetts Institute of Technology has developed a program called the Regional Entrepreneurship Accelerator Program. That's REAP. And it has been now operating in about 50 jurisdictions around the world. And each team in each jurisdiction is made up of a number of categories. So those categories are entrepreneur, and we're fortunate to have Lisa Genero from Spur Brother Farms and Burnell Lyons. And a shout out to Lisa thanks for the ambrosia apples that you see at your tables. They're compliments of Spur Brothers. So thank you for that, Lisa. The university category is Dr. Dale Keefe from Acadia and Jason Clark from NSCC King's Tech. We have the risk capital category, and that's Len Ells from the Valley Credit Union and Stephen Shaw from CBDC Hans Kings. And then the government categories, Mayor Sandra Snow, the town of Kentville, and Jennifer Tufts from the Valley Wren, who's CEO there. The corporate category is Andrew Schneer from Andritz, North America, and Director of Operations. And then, of course, Rochelle Redden-Brown, Rochelle, who you just met, without whom this really wouldn't have been possible, this whole MIT REAP initiative and today's event. So thanks, Rochelle. So about MIT, what is it? So based on collaboration across these groups, these 5 different groups, they have a process where they're looking at what's going on locally. What are the assets that you have in your region? So in our case, what are the assets in the Annapolis Valley? And how can you make the most of those? So this initiative in those 50 countries has been shown to have a significant impact on the economy and the quality of life and improvement in the social fabric of that particular region. So we hope to do that here. And what we've done is we've kind of looked at our unique assets. And this goes back to the One Nova Scotia report that a Halifax team actually went on MIT back in the day. And they came back in 2016 from their time down at MIT, or their experience with this program, and they identified ocean technology as their must-win battle, or their challenge that they felt would be a game changer for their particular economy. And that, of course, has now resulted in the supercluster and actually billions of dollars worth of income to the Halifax and, in fact, broader Nova Scotia region. So our team has recognized that, just as MP Blaise said, that agricultural technology is really at the heart of how we can grow here in the Valley. That there's certainly already adoption of these technologies in many areas, but at the same time, we know that there's still some room to grow. We know that the federal government, we know that the provincial government has identified the fastest way to grow in the agricultural sector is through the adoption of technologies. So this morning, what we're going to do is do two things. We're going to introduce you to some of these technologies at a fairly high level. We have three presenters that will talk about different technologies. In one case, you'll hear about systems that are supporting high tunnel operations, greenhousing. You'll hear about in a second presentation, decision support tools, how to make your farm operate more efficiently and easier from the point of view of technology. And then the third group is going to look at UAVs, or unmanned aerial vehicles, we call them drones, and how they might be used. Now, there's a whole variety of these technologies, and part of our ambition as this team is to make it more straightforward. Like, what do you pick? How do you make it work for your operation? How do you make the most efficient cost decision around these things? What happens if the thing breaks? Who's your Maytag repairman? Who do you call? So those are all implied questions that our team's going to be looking at and hope to become a center of excellence, or if you like, a place in the Valley that will be a demonstration, acceleration site for these technologies. So that's our end game. But first, we're starting at the beginning, going to introduce you to these technologies, and then we're going to ask you some questions about what your opinions are. What do you think? What do you think are the right priority options that we should be focused on? So that'll be the second part, and we'll come back to that in a few minutes. So now I'm going to turn the table over to our presenters. Our first presenter is a team from Korea, Byum-Sul King and Dr. Youngwon Chan, and they're from Smart Software Lab, or SSL, in Korea. Now, they've just recently incorporated a business here in Nova Scotia as Optimal Grow Incorporated. And we're grateful that they could join us and tell us about their technology that they're bringing here to Nova Scotia, because it's 10 p.m. for them right now. So over to Byum-Sul.
Good morning, Wayne.
Yep. Get a bit of volume.
Hello.
Go ahead, please. Can you hear
Good
us
morning.
okay?
Yeah.
Okay, we're just turning up your volume. We can hear you now.
Okay, good. So let me start. Good morning, distinguished guests, ladies and gentlemen. This is Byum-Sul Kim, co-founder of SSL. Dr. Youngwon Chang, adjunct professor at Department of Software Engineering in Jeonbuk National University, incorporated SSL in year 2014, together with his fellow professor and couple of students. SSL is a software specialist currently focusing on agriculture and providing environment control agriculture by intelligent control platform. Today, I'm going to explain you about the future of precision agriculture.
지금 화면 공유가 안 되는 것 같아요. 확인 한번 해주시죠.
Can you see the
presentation.
my presentation materials?
We don't see it yet, so.
비활성화 했다고 그러잖아. 가만히 있어봐야.
아직 안 나.
일단은 도망갔어.
You may have to describe what the picture looks like.
오케이,
Oh,
됐어요.
there we go. Okay, we're good. We see it now.
다음 페이지로. So we start from a global issue, as MP Blair explained just now. Amid pandemic, we learned a lot. The shortage of laborers, insufficient food production, poor logistics, insufficient supply chain, and we recognize heavy dependence on imported food. And it highlights the importance of local food supply. And now every jurisdiction put mandatory food sustainability, and on a country basis, it could be food security. Therefore, farming requires smarter, more efficient, and more sustainable technology. On the other hand, global warming also gives us fluctuated climate, which will lead us to an unstable farming. But on the other hand, this global warming enlarging arable area further north. And ESG management focusing on carbon reduction claims that cattle is a heavy methane emitter. Therefore, we need to control environment agriculture. So solutions and benefits in case of horticulture, through mulching, high tunnel, greenhouses, multiple farming, hydro farming, we can have protected agriculture, and it will make farming be less climate affected and more disease prevention. Next. And it will also make us to extend the growing season. No summer is too short and no winter is too cold. Growing earlier into the spring, later into the fall, and mostly year round, so that we can sell our products while others are idling. And it will also improve plant quality by microclimate control and precision irrigation, and also improve soil quality by micro soil management, reduce nutrient and pesticide consumption by precision irrigation with no waste, improve air quality through reduced transportation inputs. Our predicted and automated control for individual farm will make us to reduce manpower requirement, and it will lead comfort and customized farming, so that farmers provide their communities with healthy and fresh local food for much of the year. It will reduce energy use by providing consumers with a local source of fresh produce. For the animal agriculture, through environment control barn, we can provide the most productive THI, which means temperature humidity index guided environment, by AI-driven environmental data collected from inside and outside of the barn and bedding. Correlation analysis among environmental, health, and productivity data will make us to control the volume of the feeding per productivity and healthier animal will make us less disease affected and reduce the methane emission so that we can comply to ESG management. Predicted automated control for individual farm also will make a reduced manpower requirement, and it will lead us to comfort farming so that next generational farmers can join for agriculture. SSL's intelligent farming platform consists of outdoor weather station, microclimate management, irrigation and fertigation management by intelligent scale, microsoil management, sunlight management, manpower saved by predicted and automated control, and growth monitoring by vision processing. With the data collected through the machine learning and artificial intelligence, we can provide intelligent control, which will make us for bespoke farming, which we can grow customized and high value added products. It will also make us hand-free control, so it is very comfort farming. In result, we can optimize yield, we can achieve food sustainability, also comply to ESG management. These are the example of the data collected by our intelligent farming platform. The temperature, humidity, and sunlight, CO2, which is monitoring the environment. And then this is to check the soil condition, which means pH, EC, and soil temperature. With this collected data, we analyze and learning by intelligent farming platform. So this is the example of our experiment, utilizing total data of 54,300 data. We tested with 2,496 data for the duration of 48 hours to predict temperature of 5 minutes ahead, utilizing 15 minutes ahead, utilizing CO2, sunlight, VPD, humidity deficit, wet temperature, dew point. So we predicted in this white line, and sorry, red line, and actual temperature comes in blue line, shows you very high accuracy, but we take the most wider gap and we check it, and it is only 0.8 degrees Celsius. It means very high accuracy. This is the experimental farm that we built in Korea. This shows you how automated control works. Circulating fan, roll up the blanket and cotton again, and exhaust fan to pull out the warm air from the inside of the greenhouse. And we had another experiment at the cattle farm, Jiangsu, Korea, to understand and provide the best environment of the barn under various weather conditions by monitoring and controlling temperature humidity index. Here we check the temperature, humidity, sunlight, noise, utilizing our sensors, and also we monitor the quality of the air, NH3, CO2, NO2, and CO. I want to show you how other countries are doing. This is the town named El Haido in Almeria, southern Spain. Please follow this white band. This shows the greenhouses. This area covered 40 kilometers length and 20 kilometers width, almost fully covered by greenhouses. Even they utilize this kind of curved land, utilizing their specialized greenhouse technology. In 1974, as you can see, this area was typical rural agricultural area, but in year 2020, it changed it to 57,000 hectares has been transformed into a vast greenhouses to produce greenhouse crops. So now Almeria became the major supply source to Western Europe. They supply fruits and vegetables to Western Europe. In Korea, almost every county appoint 1 or 2 crops, depends on the weather condition and their specialty. So this is the example of the one special zone to grow strawberries at Puyo, Korea. As you can see, almost all paddy fields where they grow rice now turn into the greenhouses to grow strawberries. So this is inside the greenhouse and showing the regular strawberry with the 10 to 12 bricks. And they recently introduced a new breed named Kingsberry, which is this big, like as a lady's palm, and with the 13 to 16 bricks of sweetness. So as to melon, grape, and apples. So these melons, county name Seongju is fully covered with greenhouses, low height greenhouses, because melon is a ground crop. So this is just higher class than normal high tunnel, but with the automated control inside. And in Korea, even grapes are grown in greenhouses, as you can see. And also this is what how we are growing apple in Korea. I want to explain you how small South Korea is. South Korea is about 2 times bigger than Nova Scotia in terms of the land, but 70% are covered by mountain. And Canada is about 100 times bigger than South Korea. South Korea have very tiny land for living and farming, with the population of almost 52 million, while Canada has about 38 million population. GDP per capita in 2019, Canada was about 46,000 Canadian dollar, while Korea was about 36,000 Canadian dollar. As you may know well, Korea was one of the poorest country in the world because during Korean War, which broke up in 1950 till 1953, everything was destroyed. So in 1962, the GDP per capita in Korea was only $100. But we could reach to 1,000 in 1977 and 10,000 in 1995. To be such a fast growing country, agricultural backup to make us no more starvation and no more poverty was major elements, in my opinion. And climate-wise, as you can see, Nova Scotia and Korea, in terms of altitude, Nova Scotia is slightly higher in north. And then climate-wise, about 2 weeks ahead of Korea means you are colder twice, 2 weeks earlier than Korea. So what I want to explain you is climate-wise, not very much different between Nova Scotia and Korea. So now I want to suggest you, why not Annapolis Valley, the Almeria of North America, with this kind of greenhouses to grow custom-made, customized crops with the best competitiveness in the world. Thank you very much.
Thank you, Bimsul. I think there might be time for 1 or 2 questions, but just looking online to see if there are any questions for you. If people do want to pose questions, by the way, to SSL, you know, at the break, see me and I can pass questions on as well. So. Okay, so it looks like there are no questions. It looks like your presentation was so comprehensive that you've got everybody thinking about things here deeply. So thanks so much to you and to Dr. Chang.
Wayne?
Yes.
We plan to visit Nova Scotia again in January next year.
Okay.
So if there is any question, you can fix an appointment.
I will do that.
Thank you very much.
Thanks again. We look forward to seeing you in January.
Me too. Thank you. Thank you very much.
So our next presenters are Dr. Martin Tango from Acadia University and Dr. Etienne Fumu from NSCC Applied Research. Their presentation is called Reaping Decision Support in Horticulture or Agriculture, and it concerns using agricultural technologies to help with production decisions and making farm operations more efficient. So I'll turn the floor over to you, Etienne and Martin.
Thank you very much, Wayne. Can you hear me well? Can you hear me?
Yes.
Oh, thank you very much. So good morning, everyone. This presentation is co-presented between myself and Dr. Etienne Fumu, who works with Applied Research and Innovation Engineers Technology Lab. And Dr. Fumu right now is on the plane coming back from Africa. So I will present on our behalf.
Martin?
Yes.
You may have to adjust your camera. We're just seeing a portion of your screen.
Okay, let me see here. So let me see here. Is that any better?
No, sometimes there's a feature where it says world facing right on your camera.
Okay, let me go on my settings. I'm not very familiar with Zoom, so I'm more conversant with Teams. Let me go under settings. Integrated camera.
Okay, we can see you now, Martin.
Okay, so that's good.
No, but we can't see your presentation yet.
Okay, I will share. Let's see. Is there a way for, I sent this to Nicole. I'm not sure if she can.
Yeah. Nicole, can we roll it from here?
Yeah, and then I'll just say advance.
Okay. We'll just see if we can do that.
I'm sorry for that, yeah.
No worries. Can you see the screen okay, Martin?
Yes, I can see that.
Okay, so you just tell us when to advance the slides, please.
All right, wonderful. So once again, thank you everyone, and sorry for the patience. So just to recap, this presentation is jointly presented between myself and Dr. Mfumo from NSCC Applied Research. So the background is, actually the first slide, we're trying to say we are trying to enlighten that lamp with many features in there. Is the more we know more about little things, in our case about decision support, the more we know about technology to monitor the processes we are working on, the better for us. So light means understanding each concept, you're among yourself as a researcher, as well as for end user, in this case is the agri-tech industry. So this slide is just to show a vast application of using non-invasive technique to measure the properties either of a crop or of the processed water or the compounds within the plant. So the one from the left is a vast area, arable land there with a lot of activity going on. The middle is industrial hemp, and the other one I believe is lettuce. So whenever you're doing all these nice things, as also presented by Dr. Chang, we want to use a decision support system which gives us an immediate understanding of what is going on. Next slide, please. So this illustration is not as impressive as one Dr. Chang presented, but it's just, unfortunately, it's not none in the valley or in our area in question. It just shows you, when you see this, I think if you're a farmer, it inspires you. You see everything, how farm is being utilized, how access or roads and things are there, and facilities is quite impressive. If all these things work nicely, we have a very conducive living communities, and that's what RIP is aiming at. Thank you very much. Next slide. So the collaboration between Acadia and NSCC is essentially combining pure research and applied science. So by pure research, we means you just gather information and is motivated by curiosity. And the whole thing is to get knowledge. And of course, 10 or 15 years down the road, it can be utilized. And so applied research is designed to answer specific questions that uses the findings from basic research. So in other words, the knowledge gains under pure research is being used by the applied research either in industry or in research institutions, and actually similar to the center which RIP or MIT RIP is envisioning to. So it's a consolidated location where this knowledge is there, so farmers or end users can reach it. So the illustrations at the bottom essentially showing the work between universities and colleges, which is a community hub, can reach out to the industry through utilizing basic research and then applied research, which is tailored to specific client. And of course, initially as a proof of concept, if that is well understood, then you can develop a full-scale system, which essentially is tying up to what's called social innovation. And at the end users have commercial applications for it. Next slide, please. In fact, so this is one of the example where it's kind of lab scale where we grow algae. And essentially we're saying, can we monitor what is going on as algae is growing, especially in the processed water, even in a smaller system. So algae is growing, we are giving nutrients, there is light and other things. But the question is, if you can understand what is going on in the media in which the algae is growing non-invasively in real time, you can predict the yield of algae over time. Even though it's at small scale, it's potentially possible to scale it up to a bigger scale. So it needs a little curiosity in terms of knowledge, the electronics, and it combines. So this is just to show how institutions like university or Acadia and NSCC is empowering young generation of potential experts. At their college, they get their degrees or diploma, but we are empowered them when they go to industry, we have skills around this area. This is one of the work we did with an industry client. The company name is called Subtech. His name is Mather. He is a biologist by expertise, but he had a business and he wanted to say, is there a way I can improve the way algae is being produced? And this illustration is algae is being grown in a kind of controlled environment container. And essentially the goal here is to have high yield. In other words, high productivity in a smaller footprint and at a lower cost. And that's the technology he would like to promote in different parts of the world. And that's kind of an example of working with an industry partner to have a product which is highly efficient in terms of productivity, low footprint, and low cost. So real-time non-invasive monitoring. So for algae, we just grow them in a small containers. There is light, is a benchtop scale. But what is exciting for us, we adopted a technology which is a sensor, is a flame detector. Essentially, you run a small sample in a cuvette or a small area in real time with your computer. If you can sample it from this culture, it gives you what is in the growing media. You're not monitoring what's in the algae, but what's in the growing media. So it's in a non-invasive way. So this way you can readjust conditions for growth, either light intensity or nutrient additions and so forth. But is really real time, very handy. And we think this approach is what we should be giving us high productivity, high yield, and you collect a lot of data. And I will illustrate how this works. So because it's a fiber optic technology, so it's real-time invasive monitoring on algae, you can collect data and get information such as this. You use in wavelength or intensity, and then over time, and then you can use this information and say what's going on initially. And right now you see very nice smooth curves there. But after a few days, you start to notice some changes in the media by the peaks, which is shown by the arrows. There is some noticeable things. Things are start to change. So then you say, what are those? And at where does it happen? At what wavelength we were able to detect those? So that's a crucial information because for us, for algae, you are looking for lipids and protein. So then you track and say, oh, I can detect something is going on there. And you could say, is it protein or lipid? And is it enough for that time in scale in the process? Then you can adjust your process. So you can continue even monitoring, and then you realize there is a region where you get high precision of sensing, and you use that wavelength to monitor your process. So you're kind of optimizing the real-time monitoring process. And so you can actually, you can remove even background features. So in this case, you could say the biomass is changing at a certain wavelength over time. And that's a useful information to us. And also you can filter the background, like lights in the room or in the greenhouse for that matter. Those information, you say this is due to the light, background light in the space, but others are due to what is happening in your culture. So similar to Dr. Chang's work, there is a massive initiative in greenhouse operations, and all of them are around aquaponics. But the control of those problems, even though it's in a controlled environment like greenhouse, is very tricky because it's about process water chemistry, is about levels of oxygen and other micronutrients or nutrients required at low concentration and those at high concentration. And in some cases, things could go well. And the sad part comes, if some infestation happens, then you might have to close the whole operation. So, and this is, I just want to reiterate how important monitoring of the process continually in real time is important, because you can predict or you can avoid those things happen. And there are stories where greenhouses have been closed because of infestation, and that is a setback and it's complete economic disaster for company. So of course, if everything goes well, you know your costs, you can set even the price, you can even tell the customer when you're delivering your product because of applying this technique. So it's really very important. You're right, go ahead, next slide. So back to the aquaponics is crops where you have, is a process where you have two crops, fish and vegetable, and most of it you supply nitrogen source. Of course, here it's just nitrogen, but there's speciation, what exactly nitrogen should happen, and you make use of nitrogen utilizing bacteria, but then you add other things like iron and calcium, potassium, and so forth. And then, in other words, you are using fewer resources to grow your crop. And Dr. Chiang explained very well in the massive greenhouses they use. You avoid chemical fertilizer, you don't need soil, you don't need pesticides, but it's an efficient process than traditional culture, especially recirculation aquaculture is very efficient, but I'm saying at least there's a little bit better if you adopt aquaponics, and can be adopted in actually numerous locations. So that's kind of, we're trying to say the work on aquaponics, even hydroponics and other things are equally important. But anyway, this is kind of for us to emphasize how aquaponics is so important. This slide, I know I have a source, but I'm just putting anonymous there. It's just to compare aquaponics, hydroponics, horticulture, recirculation, aquaculture system, and cage pond culture. Is essentially show how efficient each of them is. And of course, all are useful if someone has one of those, but all the time you should look about water use, energy use, nutrient use, labor use, space use, and capital investment. And it shows here that there is more of an efficient process how aquaponic is. So this type of analysis is so important. So for us, we ended up developing a bench scale. Initially it was a small scale, but we ended up developing a bench scale about 200 gallons tank, a fish tank with filters and several grow beds for plants. And the reason I'm showing this illustration here, this is not a sketch. The drawings you see there, that is a drawing prepared by an engineering student. So it empowers students to have a skill in engineering drawing, like in 3D using Solid Inventor or Fusion 360. So it's an efficient way of preparing a process, a diagram for the facility, and you can quantify parts, and you can even predict the cost. And then you can embed even sensors into the process, and you can run a simulation to see, oh, how the facility will run in a typical operation. And until you gather significant data, then you can convince an industry partner, look, we can make this, and this is how it performs. And in this case, the figure at the bottom is say, in some cases, you can even have them solar power to augment or supply some of the powers for pumps and lights and so forth within the system. And it's incredible how different crops, whether it's lettuce, kale, basil, they grow almost at the same rate by us simply controlling the constituents of the processed water. I will skip the simulation, it's just to show how things come together. So this is where at the end you can harvest fish after some time. And one of the things we haven't done intensively is the quality of fish or fish health. But vegetables, we have analyzed them, what is in the tissue in terms of antioxidant or pigments and so forth. And this is a really exciting work for us. And those kind of support is what someone interested in investing in this area could be interested. And so on the day we had to take the fish, they keep hiding there. Those are bass, they hide at the bottom. So we had to hire students who has some skills to get them from the bottom of the tank. So I just want to use, so sensors is one, but another way to monitor crop is by using infrared technology is called NDVI. So it's just an index. You take a portable sensor, it uses infrared, you just direct to the plant, it gives you an index. And that index normally is between 0 and 1. That index, it just gives you a range whether the plant is healthy or not. And you can correlate to the nitrogen level, potassium level, iron level, and all those things. So it's kind of a faster way for a farmer or a user to apply. It's just a portable probe. So we are trying to say that is an easy way than taking samples to the lab and say, tell me what is in there, iron, all those things. So you can use this technique easily, and within a few minutes, you have the data. This is how one of it is called GreenSeek. It's about 7,000 devices we bought from a farmer who is a representative of a company, but we were able to use it in our greenhouse application and get data. This is another one, it's just trying to say whether it's in vegetables or vines or apples or that, you can use this technology to monitor the constituents of the leaves or the crop, and therefore get an immediate information whether it's healthy or not. And this is our team, how we have been working as a group. The fellow in the middle, this fellow here, he's the end user for the aquaponics, and the rest are research assistant. We work cohesively as a team just to illustrate is a work of collaboration and empowering students and research associates. So that's all I have that Dr. Etienne and I, we work together to try to promote this approach, and depending on the end user, the technique or non-invasive technique we use is different. Thank you very much for your attention.
Thank you, Martin. We do have a question here, wondering about aquaponics, and is it more or less efficient in cold weather climate compared to traditional hydroponics?
Excellent question. Okay, so that is about what Dr. Chang earlier mentioned about process parameters. So temperature, relative humidity. So because at lower temperature, what will happen, because what works better in aquaponics is if the quantity of nitrogen utilizing bacteria is sufficient. There are two families there. One is converting nitrogen to NO2 or nitrogen dioxide or nitrous oxide. And the other group converts NO2 to NO3, which is a nitrate. So at lower temperatures, those microorganisms don't work efficiently. So because the efficiency of working is reduced, then indeed, yes, at lower temperature, the aquaponics won't work as well.
Mm-hmm.
Yes.
Okay, thanks for that. And I think we have time for one more question. So I'm just going to ask Martin. So just reading this now, is there a problem with nutrient salt accumulation in the solution?
Yes, the word is salt.
Yeah, I think the question is more to do with the accumulation of salt over time in the growing medium, in the solution itself.
Okay, so this is how I can respond it, because they use the word salt. So in other words, if they are using marine or salty water, then indeed, yes. But if it's a fresh water is being used, this is what happened. You keep monitoring the processed water, and not all the nutrients you added are utilized. So what invariably means, there will be an accumulation of those things. So they can accumulate in different locations. One is in the root system of your plant, or there could be a slight debris at the bottom of your growing bed. So there will be some insoluble particles or things which are not dissolved, they accumulate at the bottom. And in fact, those can even clog the system, especially the pump, because of course there are sand particles. So yes, there is a gradual accumulation, and that's why monitoring of what has been applied, and it's a little bit difficult to detect what has been utilized by the plant. So if you map up the utilization rate, what you have applied, what is in the solution, what has been utilized in the tissue, then the difference is what the person is referring to. There will be accumulation because not everything has been, and you are recirculating things. So indeed, that brings the question was, at times you have to purge some of your processed water. You take some out and add fresh water into the system to minimize that degree of accumulation of minerals.
Okay, thank you very much. And for that presentation, the very broad reaching on aquaponics hydroponics, and container growing. Very much appreciated. Thanks to you, Anna, Jen, Martin.
Thank you very much, Wayne. And thank you everyone for listening.
So our final team of presenters, Thomas Harrington from Perennia and Dr. Matt Van Conant from NSCC Environmental and Agricultural Applied Research, will discuss the use and benefits of drones in different agricultural projects and some potential future research opportunities. So over to you, Matt and Thomas. Oh, okay.
All right, hello everyone. It's great to be here and thank you for the invitation to present. So my name is Thomas Harrington and I'm an agriculture technology specialist with Perennia. So I was asked today to do a brief presentation on drones and how we've been using them at our organization. So next slide, please. So a little bit of background. I grew up on a small wild blueberry farm in Nova Scotia and went to the AC and did a degree in environmental management. And after that, I worked in commercial wild blueberry farming and also in precision agriculture. So I've been working with drones for a few years now. I was part of a team that had some of the first drone flights over wild blueberries in the province and kind of worked on a few different projects since then. So I've been kind of working in this field for a little while. It's been exciting to see the changes and things that have happened in the industry and how drones have been used. Next slide, please. For those who are unfamiliar with Perennia, I thought it might be good to just give a little background on our organization. So Perennia is a provincial development agency with the mission to support Nova Scotia's agriculture, seafood, and food and beverage sectors. So we have offices in both Truro and Kentville, and also now a new lab location in Wolfville. Our company has grown quite a bit in the last few years, and we now have an extensive list of services in areas including quality and food safety, product development, and we've also started offering some lab services, including our plant health lab that's working with the grape and small fruit industries to do virus testing. And in the last few years, we have also expanded our mandate into the fisheries sector. So we've undertaken initiatives in this area in food safety and product development. So you can check out our website for more details on any of these programs. Next slide, please. So at its core, Perennia has always been focused on agriculture, and we offer many services in this area. So our extension program, we develop workshops and other training material, as well as offer production advice, in-field disease and pest identification. And we also offer management advice, help address industry issues, and help producers be environmentally and economically sustainable. And part of our agriculture services includes our field research team, where we offer comprehensive trial and research support on contract. Yeah, so I'd say we're fairly new into our venture into the drone world. This was really our first season that we've dived deep into drones and trying to incorporate them as much as possible into our operations. So I thought I would give just a brief overview of what we've been using them for, how they've been working for us, and just some examples of some projects and things that we've used them with as well. Next slide, please. So I kind of broke it down into 4 categories that I think drones have been most useful for us. And at the really basic level, they really are helping us to tell a story. So I think with drones, there's a lot of excitement about what they can do and future uses and identifying diseases and yield predictions and things like that, which I think is amazing. And there's some incredible opportunities there. But at the very basic level, just having pictures of things that are happening in the field are extremely useful. And we've seen that a lot. And I'll give a few examples of how we've used those images. So these are the drones that we are currently using. They're just consumer level drones, fairly basic technology. By today's standards, things have come a long way in the last some years, but they're commercially available. So we're using a Phantom 4 Pro that has a conventional color camera. It's a 20 megapixel, just red, green, and blue camera. And we've recently acquired a multispectral Phantom 4 as well. And so in addition to red, green, and blue conventional camera, it has 5 individual sensors on it that do red light, green light, near infrared, and red edge wavelengths. And just for some context, on the top left there is an image that would come from a conventional camera, and all the other images are what we would get from the multispectral camera. So you can see it's just a lot more data. It gives us a lot more opportunities for processing and diving deep into the images and the data that we get from a field. And so I mentioned we were using drones to tell a story, and this has really come to light in the past number of years with the situation where we're not as easily able to host in-person field days and things like that. So drones have been an excellent tool for us to be able to gather imagery and video and show those in a virtual format. So Perennia has conducted some virtual field days the last number of years, the last few seasons, and this past season in particular, we tried to incorporate drones as much as possible because they're a great tool to do a virtual field tour. This is an example of a wild blueberry field. So our wild blueberry specialist gave a presentation as part of this format, and we can do a virtual flyover of the field and talk about things that he might look for when he's troubleshooting a field or things like that. This is another example as well from our virtual field day. We have our dairy specialists presenting and talking about silage packing and different tools. We can have drone imagery there and telling the story really what's happening without people actually being on site. So I think we're exploring more opportunities to incorporate it, but it's been a really great tool. And now we have these resources that we can share at presentations and things down the road as well. And as part of telling the story, even having images for things like our fact sheets to be able to talk about things that we're seeing in the field. This is a fact sheet talking about riparian zones. So to have drone imagery of these areas and be able to give another perspective. You know, if you're on the ground looking at this from the edge of the field, you might not be able to see the full picture, but to have drone imagery and give this to a producer, you can see much more about the effect of the riparian zone, not just from the field edge, but as a whole ecosystem level to be able to see that bird's eye view. And so one specific project that we were contracted to do was on behalf of the Nova Scotia Farm Loan Board. We did a site evaluation of 8 Nova Scotia community pastures around the province. And this was really the first time that we incorporated drones into a project in a big way. So there's 8 sites across the province, as I said. They're spread out from one end to the other. And drones were a really great tool in this project where we gathered imagery, but we also did some measurements and calculations based on the data as well. So at some of the sites, we surveyed them completely with the drone and were able to process the imagery together and calculate things like elevation maps. And we were also able to estimate fencing lengths and other infrastructure, things like water lines and pumps and things like that. So it was a really great tool for this project that made it really, really quick. We could do the survey in about half an hour at a lot of these sites, and they'd be able to take that data back to the office and do calculations and really make some nice maps that were incorporated into this report. And that was one example from a site that was actually abandoned. So it was very tough to physically walk over the site to see all corners of it. So with a drone, we were able to survey the entire site with high accuracy and calculate things like elevation maps for sizing pumps and access to water and that kind of thing. So NDVI was mentioned as a tool before, and we're I would say at the stage of exploring how to use that and how to incorporate that into our offerings. So currently, we're using NDVI on some of our research trials, and it's a great tool for providing an overview of general health of your crop. And so I think there's still some work to be done about how to translate that to information that a producer could actually use on their farm. It is highly valuable, and it basically tells you where it's good and bad, but there is, I think, a lot more work to be done to fine tune that, I guess, to bring into problems. So a previous slide was an example of a trial that we did locally with some winter wheat seeding rates. And you can see with the NDVI, the more vigorous growing areas of the field show up brighter green, the less vigorous fields show up kind of red or spotty red. And so you can really see when you show this to a producer, talk about seeding rates and establishment, it's very quick and easy to see the differences in the different treatments. And so basically the way NDVI works, I won't go too much into detail, but a healthier plant will tend to reflect near infrared light more than a stressed plant. And there's a calculation in a formula that compares near infrared light to the amount of red light being reflected, and that converts this into an index of -1 to 1, where generally healthier plants will be closer to 1, less healthier plants will be closer to 0, or bare soil will be in that range too. So just one more example, this was of a field that had a cover crop treatment on the bottom side of it. The top did not receive a cover crop. And so NDVI was calculated on this field, and it makes it really easy to see differences in establishment. You can see on the top, there's much less coverage of the soil. On the bottom, where the plants were established, it shows up much brighter green, but you can also see that it's not an even stand. So it's something that you could also go to the field and troubleshoot a bit more, or maybe take some on the ground measurements and determine what is actually causing the differences in establishment. So that was pretty much it. I just wanted to give, like I said, a brief overview of how we've been using the tools. And I think there's lots of opportunities for drones, and we've got a lot of data to work with over the winter as well. So we're kind of making our plans for next year about how we're going to be incorporating drones even more into our operations. Well, thank you. I'll hand it over to Matt.
So I'm Matt Van Conant. I'm a research scientist at Nova Scotia Community College. I run the Environment and Agricultural Technology Lab. Been here for about 4 years, I guess now. So I didn't want to just copy what Thomas said, because we previously worked with NDVI as well. Thomas gave a great overview on exactly what NDVI does. So for my little section of my talk, I'm just going to talk a little bit about some of the other drone work that we've done, which is really just one major project. We're still exploring some other things, but anyways, I'll get into that. But then just talk about some other research, agri-tech type stuff that we are either getting into or have done previously. So NSCC, what you may or may not be aware, we're really, really applied. That's 100% of the work we do with industry. We're really connected to industry to answer these research questions that industry wants and needs. And so, I mean, for any producer out there, whether it's Acadia, Perennia, or ourselves, just let us know what you guys need. We're into solving problems, whether that's on the ag tech industry or any other type of industry. So you can go to the next slide, please. So one of the things that we've done, you can move me down actually, just to show what the drone is. So we have actually a suite of drones. We have our multispectral camera, which Thomas just talked about. We also have a hyperspectral camera, which actually breaks up. When Thomas showed you that wonderful picture of all the different wavelengths, the red, green, blue, red edge, the hyperspectral actually breaks it up into individual bands. So we have that, and that's really on the theoretical, I wouldn't say theoretical, so to say, but a lot of it's still being explored of what we can pick up from plants on that. So I'm not going to talk about that today, but what I am going to talk about is our LiDAR sensor, and one of the projects that we actually have been exploring with the Christmas tree industry. So this LiDAR sensor is actually, what it does is sends out infrared pulses of light. And what you can actually see, and if you look at this LiDAR data side view, it actually gets reflected back and the sensor picks it up. And based on the GPS location and everything, it gets all technical, but basically you can figure out the formation of something. And so one of the work that we've been doing with the Lunenburg balsam fir industry is actually figuring out if it can be used for determining tree height. So the Christmas tree industry in particular naturally generates in Nova Scotia. So they grow it in like side of hills, like very rough terrain where you wouldn't grow any other type of crop. And one of the biggest issues they have is they have to manually survey. So when they, in September and October, they have to figure out how many 4-foot trees they have, 5-foot trees, 6-foot trees they have, and they have to do that manually. And, you know, they're walking 60 to 100 acres manually. And so that's a lot of work. And we can actually, and so that takes several days, up to a week in some cases. And we can actually fly that 60 to 100 acres in less than an hour with this drone. And what we are able to do, and what we've been working with them to do, is actually fly it and determine that through different algorithms, is actually determine tree height for them. And so we can actually locate, without them actually having to be on place, like on the site, locate how many 4-foot trees they have, how many 5-foot, 4.5, and the number of trees they have, just by flying this drone. And we're actually working with them on another project to further advance this, and we're looking at tree grading. So not only will be by early 2022, because we're still working through the data, is not only will we be able to determine the tree height, the number of trees, but the grade. So that will tell us, that will tell them what sort of income they may be able to generate from that. So if they have so many 4-foot trees, they know, and they're at a certain grade, they know how much money they're going to make and give them a good estimate. Next slide, thank you. So that was one of our big drone works, and it's still, we're still looking into other things. But one of the other aspects of agri-tech is also geospatial analysis. And I'm sure many of you guys are aware of COGS, the Center of Geographic Sciences down in Lawrencetown. One of the projects we did a couple of years ago with the grape growers was actually taking all sorts of weather information across the province. And we basically are able to take a crop and score it based on what that crop prefers, what type of weather it prefers, and score it based on that. And we're able to create a geospatial tool with using GIS and analyze that to determine what areas across the province are suitable for growing that specific crop. And in this case, it was grapes. And so any producer that's looking to grow grapes, whether you're looking to expand the industry or looking to buy land, you can actually be able, through this tool, can actually determine what area, if it's good to grow grapes or not. And we can do that across many other crops as well. And then finally, we actually have one other project just going to start up in the growing season this year using soil sensors, moisture soil sensors. And we've actually are still in the midst of trying to figure this all out. But what we're trying to do is connect the soil sensors to an irrigation system and only irrigate when it's needed. And so instead of haphazardly irrigating, having a producer haphazardly irrigate or irrigate based on feel or just whenever a normal timing system, having these soil sensors in place and connected to the irrigation system will only irrigate on a previous setting. So if it's at, maybe you want it at 70% field capacity or 60% field capacity. And of course, it won't irrigate if it's raining and all that, because it'll take that into account. So you're only irrigating when needed. And a part of that, of course, you may also have the sensors set up differently. And so you could just do like, oh, we'll only irrigate throughout the growing season if it reaches, 70% field capacity, or you could have it set up potentially to set up to only irrigate 70% field capacity during the first part of the growing season, but maybe it's fruiting season and you want to make sure there's you're almost at 100% field capacity all the time, making sure that fruit's growing as well. So what this can do is actually increase your efficiency because you're only irrigating when needed, as well as increase your yield potentially because you're again focused on specific seasons, or even better is you're just being more efficient and reducing your inputs. And that's it for me. Willing to take any questions. Okay. So I'm assuming this will be, well, it could be for both of us, Thomas, but I'm going to leave it to you. I'm going to leave it to you. What about the idea to use drones for bird protection in a vineyard?
I think that's a great idea. Have not heard it done locally, so yeah.
Yeah, there are some there are some Transport Canada rules about not disturbing wildlife as well, so you have to take that into consideration. But yeah, there can be some potential there. Yep. Oh, sorry, I didn't explain that. I totally skimmed over that. I apologize. The green was really suitable, so you can grow. So it should be really, you should grow there, or it should be very suitable to grow there. Red indicated that no, it's not very suitable, so not very good.
Do you have any ideas on using drones for documenting the clear cutting of our forests in the province of Nova Scotia?
So yes, you can do that. You can use a multi-spat, or you can use, you know, general RGB, but one of the main things is you could also use the LiDAR sensor to pick up what trees are remaining and get a percentage as well. No, because it's, again, we're on the research side, and that's very much research side. Don't get me wrong, it's just about funding always. So we're always looking for partners to progress this type of stuff. They say precision ag can and will give us 70% more root yield. Can you speak to remote sensing? So the idea there is I mean, 70% more yield seems a little high to me. But one thing it can do is just lower your inputs, I think, is because as you saw with Thomas's presentation, the red areas on a field, you're just focused on those because you don't need to truly focus on the green areas because they're growing well. And so if you're able as a farmer or producer, go to those red areas and determine, oh, it's a pest outbreak, you're there early. So you only have to spray that area once, or, you know, spray that area and focus on that area instead of the whole field. As for increasing 70% of your yield, that seems rather high to me, but there are potential for, say, for irrigation that you're, you know, if you're monitoring constantly, you're not going to lose as much yield to pests, to disease, and all that. So there's, you know, potential for less inputs, but higher yield in that case.
Yeah, and I'd say it's sort of the main issue with precision ag in general and remote sensing. It's data is great. Everybody loves to have data, but a lot of the producers are burdened with data all the time. So to get it in a form that is actually going to be useful to your operation. So remote sensing, for example, if you get satellite imagery that is NDVI or is providing crop recommendations, it's how do you get that into a form that you're going to use on your field? So whether it's a prescription fertilizer application or something that's actually going to translate into dollar savings is, I think, where precision ag has caught up a lot now that there are the tools, like the machinery is able to accept that type of data. There's data management tools that you can actually automate some of that process a bit, or you could work with an agronomist that maybe makes these prescription files and all the producer needs to do is put them into the machine and apply them. So I think that is where remote sensing really can start, maybe increase yield a bit, but it's more about decreasing inputs a bit as well to kind of give that balance.
That's great. Thank you very much. So that kind of concludes the presentation part of our agenda. And as we said at the outset, this is really a two-part process. You know, the idea is that we'd like to hear from you. So we're going to kind of turn the podium over to you all. The idea being that, you know, I remember Who Wants to Be a Millionaire, the TV show. And, you know, people often say, well, okay, who's the smartest person in the room? Well, it's the room. You know, when you're on that TV show, you have options, right? You can say, well, I'm going to phone a friend and that's the smartest person I know, and they're going to have the answer. And so people phone their friend and they do pretty well, actually. They, in fact, according to my source here, they get the right answer 65% of the time. So that's pretty good. And remember, they're under pressure, right? Because they're on the TV show. But when the contestant says, I'm going to ask the audience gets it right 91% of the time. So that's why we want to ask you about this stuff. We think that there's lots of potential here in the Valley. We think that we want to be the center of the universe with respect to these technologies. We think we have the capacity, the expertise. Already people are in this space. They're active in this space. So we want to enlarge that, but we do want to hear from you. As I say, it concludes the presentation part. We're going to be, for those online, signing off, but we will be in touch with our questions to you virtually. And we're going to take a break now here in the room and then reconvene and have our consultation conversation. So please take 15 minutes. We'll be back at 1:45. So we'll see you then. Oh, sorry. I'm also going to give you a quick reminder that the emergency exits are located where the exit signs are. And contact the Valley Wren. Rochelle's email is on your invitation, or get a hold of me and we'll happily get any further questions or a discussion to the presenter. So thanks very much, everyone. And we'll see you back here in 15 minutes.